Okay, this is the video for topic 7, section 1, adding and subtracting polynomials, or adding and subtracting like terms within a polynomial. There's some definitions first. A monomial is a real number, a variable, or the product of a real number and one or more variables with whole number exponents. So a monomial, 5 would be considered a monomial. X would be considered a monomial. 3x squared y to the 5th would be considered a monomial. 2/3 would be considered a monomial. 2/3 x squared would be considered a monomial. What's not considered a monomial would be x to the 1/2, not a monomial expression. And then a binomial is composed of two monomials, 5x squared plus 7, 3x to the 4th minus 2x to the 5th, simply x minus 1. Those are binomials. Trinomials composed of three monomials, so x squared minus 5x minus 6, x squared plus 2x plus 1, 5x to the 4th minus 3x cubed plus 7x squared. Those would all be considered trinomials, okay? And then a polynomial is composed of three or more monomials. So once we get past trinomial, we don't continue to say, well, that's a quarter nomial, and that's a quint nomial, and that's a, we just go with polynomial once we get past the trinomial. So a polynomial is composed of three or more monomials. Degree of a monomial, so if we had like 4x cubed y squared, that would be considered a 5th degree monomial. I add the exponents. Okay. Or if I had 2x, that would be considered a 1st degree monomial. If I had 3 or any constant, that's a 0 degree monomial, because technically this would be like 3x to the 0, because anything to the 0 power is 1. And so if it's just a constant, then it's a 0 degree monomial. The degree of a polynomial is the sum of the greatest degree term within the polynomial. So if I had 5x cubed y squared minus 3xy plus 7x squared y minus 2, okay, the degree of this monomial is 5. The degree of this monomial is 2. The degree of this monomial is 3. And the degree of this monomial is 0. So this polynomial is a 5th degree polynomial because that's the largest. Okay. We're not going to be interested, you know, when we're just adding and subtracting like terms. Yeah, we're going to be working with things like that. But eventually what this is leading up to is we're going to be working with quadratic equations. And quadratic equations are 2nd degree. So we're going to be working with, you know, x squared plus 10x plus 25. And we're going to explore the graph of that. We're going to, just like we did with linear equations, we're going to do everything we can to this quadratic equation, including setting it equal to 0 and solving, just like we did linear equations. Standard form of a polynomial is when you write the terms in descending order of the exponents. And if there's more than one variable, you go alphabetically. So like this term up here is not in standard form. technically I should have this in between the 5 and the 3, because I would write it in descending order of the x's, because x comes first alphabetically. So it should be, right now this is cubed, this is the first power. This 1 to the second power should be in between there, okay? So that's standard form. And the significance of being in standard form is that when we get to quadratic equations, that's the form we need them to be in to graph them, or to put that into the quadratic formula eventually to solve these things. Okay, so obviously the one I've written there is in standard form. You know, we could have 3x to the 5th minus 7x to the 4th plus 2x cubed minus x plus 11. The way I check it, 5, 4, 3, 2, 1. So it is in standard form. 0, forgot 0, sorry. Okay. So again, some of your homework will be just, hey, write this polynomial in standard form. So for this polynomial, the cubed term would come first, and that negative belongs to the 3. So to put this in standard form, we would put negative 3x cubed plus 6x squared plus 7. And now we're in standard form. For this next one, the 8y squared needs to come first, and that negative belongs to it. So we would write negative 8y squared plus 2y minus 3. And then combine like terms and write your answer in standard form. So like terms are terms that the variable parts are exactly alike. And if the variable parts are exactly alike, you can add the numbers out in front and to combine them, and the variable part stays the same. Okay? So looking here, I like to write it down, and then I like to, is there anything that goes with 4x squared? Yep, there's another x squared right there. So 4x squared minus x squared is 3x squared. I do the addition or subtraction, and then the variable part stays the same. And then here's negative 3x plus 3x. That's going to be 0. So my answer is just 3x squared. So I take this and I write it on a piece of paper, you know, from the online homework. And 7y cubed, anything to go with it? 5y cubed. And 7y cubed plus, I look at the sign in front, 5y cubed is 12y cubed. And negative 3y minus 2y is minus 5y. No need to break my lead over it, geez. And then the nothing to go with is 7, so minus 7. So we've combined like terms. They're gonna have you combine these vertically too, and they're gonna show up in the online homework like this. It'll be 4x squared plus 2x minus 3, and then we have 3x squared plus 6, like that. There is no linear term here in the middle. And so we just add them in the column. So this plus this is 7x squared. 2x plus 0 is 2x. And negative 3 plus 6 is plus 3. Personally, I would rather do these up here because this isn't the way, you know, when we're applying adding like terms, we're not going to take the time to go out and write them vertically and add them that way. Okay. But it is in your homework, so we do need to know how to do that. So this next one, I would write negative 2x squared plus 5x minus 7, and then we have 3x plus 7. So nothing to add to the negative 2x squared. 5x plus 3x is 8x, and negative 7 plus 7 is 0. So there's my answer. Okay. I would prefer this not be written with the parentheses, and I can fix that. That's minus x plus 9. So nothing to go with 3x squared. 2x minus x is 1x, and then nothing to go with the 9. Here we have negative 2x squared plus 5x minus 7 plus 3x plus 7. So nothing to go with the negative 2x squared. 5x plus 3x is 8x, and minus 7 plus 7 is gone. Negative 2x squared plus 8x, which is the same problem I did above. Wonder why I did that. Don't know. Show you two different methods. Who knows? And then subtracting, and this is probably the most important part of this section, is how do I subtract these polynomials? And what I like you to think of it as is, before I do anything, combining like terms, anything, I need to distribute that negative. Okay, so rather than thinking of it as subtraction, I would rather think of it as, well, first we need to simplify this whole thing by distributing that negative. And so what that does for me, this first one stays the same, and then that becomes minus 3x squared minus 5x plus 8. And then I just combine like terms. 6x squared minus 3x squared is 3x squared. 3x minus 5x minus 2x. And negative 2 plus 8 plus 6. And you must remember to put your answers in standard form. If you don't, it's going to tell you you're wrong. So it has to be in descending order of the exponents. Okay. Over here, again, I can just drop those parentheses and then distribute this will give me a minus 4x squared, and distribute it to here will give me a minus 6. And so that gives me minus 4x squared, there's nothing to go with it, minus 5x, there's nothing to go with it, then minus 6 minus 6 will be minus 12. Notice that when I add those, I try to put in standard form at the same time. Okay, so that is it for section 1.